Welcome to the last video of our series on natural hazards, weather. This one, we're going to talk about how you can predict the weather using knowledge that we take in the measurements we talked about in the previous videos, especially if you look at the way the air fronts are moving and if you look at pressure and temperature. All right, so let's talk about that. There are two main kinds of weather systems. You have high pressure systems and low pressure systems, right? And they come behind the fronts. Air tends to flow from high to low pressure. So if you have a low pressure system here and a warm pressure system here, the air will tend to flow that way from the high pressure to the low pressure. So that way, right? So that makes sense. The high pressure will push into the low pressure. And in that way, the air will tend to flow from regions which are colder to regions which are warmer. As the air sinks down to replace the cold air, warm air rises and then replaces the cold air from where it came from, which creates circulation all throughout the atmosphere. And that's very important for weather systems. And in a more advanced series, I talk about that when I talk about high school Earth science and how the entire circulation in the planet matters for weather as well. Now, at a small scale, a local scale, a cold front tends to bring heavy and brief precipitation, right? And it's followed by a high pressure system, which then causes sinking cold, dry air to stay around. Now, normally, right before the whole cold front comes, the pressure drops because what you have is cold air pushing the warm air up, and that rising hot air causes a pressure drop. Now, eventually, as the cold front overtakes it, it will cause the pressure to be high, and a high pressure system will stabilize. But the pressure will tend to drop before a cold front comes. So, questions in the test that talk about drops in pressure associate that with a coming cold front, and therefore with heavy precipitation followed by cold, dry air staying behind. In a sunny day, no clouds, right? That doesn't mean warm though, because it's a cold, high pressure system that's staying there now. Now, a warm front is the opposite. It will bring light, long lasting precipitation, followed by a low pressure system, which is warm air, which tends to rise, it tends to be hot, and with it, cause evaporation and therefore humidity in the air. And therefore, you're going to get more clouds, more precipitation if it stays that over the air, especially if there's surface water in that area. Meanwhile, on the cold front, you have cold sinking air, which causes sunny, clear, calm skies. Right? So a high pressure system equals sunny, clear, calm skies. Colder. Warm pressure system, a low pressure system, will be cloudy with precipitation because of all the humidity that heat is causing to be gathered in the atmosphere, leading to more clouds and more possibility of precipitations. A cold front would be anticipated by a drop in pressure as the warm air rises to be replaced by that cold air, and massive storms will fall. In more severe weather will tend to happen that way. A warm front will rise over the cold air and slowly but surely form long clouds, which drop rain slowly, if any at all. And that is the difference between them. And here in this picture, you kind of see the difference between them again. High pressure systems tend to rotate clockwise and cause sinking dry air, versus a low pressure system that tends to rotate counterclockwise and cause rising moist air and therefore more cloud cover, less sunny days. But before a high pressure system comes, the pressure actually drops. Before a low pressure system comes, the pressure actually rises. And that's the cold and warm front, respectively. All right. So you can use this to help predict how it's going to happen. In fact, when it comes to severe weather, you're usually going to have a low pressure system because it's going to be very hot with a hot surface and a lot of water, especially if it's over the ocean. And that can lead to a lot of evaporation, a lot of humidity in the air. Now, if that gets hit by a cold front, boom, thunderstorm, hurricane, all those kinds of awesome things. The one thing I didn't talk about that much is that the way that the global winds move carries storms around and change the weather patterns as well. A hot air is constantly moving from the tropics towards the temperate areas into warming up the poles, and polar air is coming from the poles to replace it. Now, these things get pushed by the high, strong, fast winds in the high stratosphere, which is called jet streams. And the one over the United States literally do this little bit of an arch like this. So because of that, cold air will tend to sink from the poles into the western part of the United States, get warmed up here in Texas, pick up moisture, rise back again, hit cold air, and then cause long-lasting precipitation, and then cool as it goes back over the northeastern part of the U.S. That is a typical thing that happens. But that jet stream can shift up and down depending on how strong the cold polar vortexes are or how warm the air is down here. Now, in this particular example here, because you have cold air hitting warm air, of course, you're going to have a lot of thunderstorms in the middle, especially if pushed by the jet streams, the weather systems come from a hot region too. And you can bet that any storm that forms this way will travel down what we call the tornado alley, right? Can you see now why that's the most part of the United States that gets to get the most tornadoes? Oklahoma, northern Texas, Kansas, and all of those other Midwestern states are right in the corridor where cold air hits warm air, and that's why you get a lot of that precipitation. Another thing that's interesting too is that the type of precipitation you get depends a lot on the air. If the precipitation forms over very, very cold air, it tends to be snow. If it forms over a cold air but passes through warm air and then through cold air again, it can be either sleet or freezing rain. So really cold rain, or like these chunks of ice that are vertical. And if it just drops through warm air, which is what happens when tropical weather with summer thunderstorms and things like that, then it tends to be more normal rain. Now, the size of the rain also has to do with the fronts. You're going to have lighter, thinner rain in warmer fronts colliding with cold fronts. When the cold front collides with the warm front, you're going to have more torrential, thicker rain because it's a lot of water condensing at once. All right, so the last thing I want to talk about is this idea of a squall line. And that's just a line of thunderstorm formation that happens in the edge between a hot, low-pressure system and a cold, high-pressure system. In other words, a cold front invading a warm front. Because you're going to get that layer of hot air rising as the fronts collide against each other, you're going to get at the edge of that collision literally a line of clouds. And it's so beautiful to see, but it's also spells disaster and thunderstorm and lightning and possible tornadoes. This is what a squall line is. Now, of course, tornadoes will tend to be more evident when there's a really big difference between the high and the cold air in terms of temperatures, causing a lot of updraft and a lot of air circulation in the upper atmosphere, leading to circulation that can lead to tornadoes. All right. If you see a weather map like this and they start asking questions like, for example, where would you expect a lot of rain? Well, if you see a cold front coming in and a hot area right next to it, like Florida has hot air and a cold front coming in, that's going to be massive storms, which is why there's so much lightning. It's the lightning capital of the world because it's constantly blasted by cold fronts, but it's a hot area and a lot of humidity surrounded by water. And so that's why you're going to have a lot of that. But you can also have low pressure systems without humidity. All right. And that's just hot air just sitting there. You can have high pressure systems without humidity. Now, you can even see here an occluded front because this cold front is overtaking the hot front at this area right here. And so you're going to have that stagnant air here with a lot of rain dumping. And that's what's happening right there, right? You can have stationary fronts when a cold front and a warm front collide against each other. You can see it happening up here. And that's also going to cause a lot of rain right along the edge of the collision. But because there was warm here, a low pressure system, so like warm air, and then there's a cold front coming in, there's going to be severe thunderstorms probably forming in that area. So what you're looking for is a warm mass of air being hit by a cold air coming in. That's going to cause massive storms. All right. So why is it causing rain and snow up there? It's because it's really cold, right? So if that's precipitation, it's going to be cold on a higher polar regions. And there you go. That is weather systems and participation. A lot of the questions are going to basically be out of the whole, oh, well, there's low pressure. What's coming? Oh, it's a cold front. And therefore a lot of thunderstorms. And then afterwards, cold, sunny, dry air. Oh, there's a high pressure coming. Oh, that means that a low pressure system is falling right behind it. And therefore, you're going to have maybe a little bit of rain and thin clouds, very cloudy system, a lot of humidity afterwards. because a warm front is coming over in a low pressure system. So these things hopefully made sense to you. I hope you find this helpful. And that's it for this play series on the weather. I will see you next time. Don't do anything that would make your mom proud.